So why do we really need variables in our programs? Well, the truth is, it's only one reason. Change. To add interactivity to our programs. Think of it like this. If you watch a movie once or 20 times, no matter what, that movie is exactly the same as it was the first time as it is on the 20th time. It doesn't change, the story doesn't change, the outcome doesn't change. What variables allow us to do in our programs is add change. So for example, if you're using a calculator, no matter what data you put in, you're always going to get an appropriate outcome. If your calculator didn't give you a different outcome every time, it'd be pretty useless. If it always gave you, say, 7, it'd be the worst calculator ever. So the same thing works in video games. If you're playing Super Mario, deciding when or even if to jump can completely change the outcome of the game. So that's why we add variables to our programs. So what is a variable in reality? Well, let's take a look for a second. There are three things that define a variable. We're going to use the bucket analogy to help us explain this again. So the three things, first thing is the type. The type really kind of think of it like this. If this is the bucket analogy, it's really the material the bucket is made out of. Okay, so maybe it's metal, maybe it's wood, I don't know. The second thing is an identifier. It's what to call the bucket, all right? So it's some kind of name. So for example, maybe this bucket holds water. So it might be our water bucket. And the third and final thing is the value that it holds. In this case, it might be how much water. But in other cases, it might be holding a bucket that holds somebody's name. And it might be the player's name in a video game or something like that. And the name might be Steve or Bob or whatnot. In C#, we have 5 different types of values that we can work with. So what we're going to look at now is we're going to break these 3 pieces down. We're going to start off with the type and make sure that we get through this in detail. The first type of data that we can hold in C# is an int. An int just means a positive or negative whole number. Now there is a minimum and maximum range, but you rarely will ever actually hit that because we're talking in the billions here. The next number, the next data type that we're going to work with is called a double. Very similar to the integer, except that it can also hold decimal values, so positive or negative decimal values. Decimal number. Let's throw a few examples up here just so you realize this. So this one might be the value 17. Down here we might have the value 3.2, or you might have the value 5. Just because it doesn't actually have any numbers following it doesn't mean it can't still be a double. So the next type of numeric type we have is something called a byte. A byte is very interesting. It is a positive number from 0 to 255. So there's 256 possible values. It could be any one in there. The next type we're going to look at is probably one of the most used types, and that is going to be a string. A string is nothing more than text. Now, in past examples that we've seen in previous work, it's always been inside of quotations, and this is going to be pretty consistent throughout your whole time using C#. So you might have something like this. Bob. You also might have something like this. 525. As long as it's in quotes, it's going to be treated as text, not a number. So if I did something like this, 525 plus 5, I'm not going to get 530, I'm going to get 5255. And the final data type we're going to look at is something called a bool. A bool is a very special data type that can only ever have 2 values, true and false. That's it. This is something we're going to use much later. The main 2 you're going to use in your entire time using C# are going to be these 2, int and string. You'll rarely use byte and you'll rarely use bool. The key to using these different data types is knowing why you're going to use each different type of data. Well, the reason being is that as programmers, our job is to be as efficient as possible. But we also need to know what type matches what circumstance. So for example, if I'm trying to store somebody's name or address, I have to use a string because there's text involved. Whenever there's text, it's always going to be a string. Bool is just to store true and false values, so there's only going to be very special circumstances. Now, for the numeric types, you got to think about what type of values you're going to be storing. If you're talking about somebody's bank account, you're probably going to use a double because there's usually dimes and pennies and stuff like that to keep track of. So you might have $2.53, so 2.53. So that's going to be a double. Integer is when you're dealing with whole numbers only, and these numbers can get pretty big. A byte is only when you're dealing with positive numbers from 0 to 255. So that means like maybe somebody's age. You know they're never going to get up to 255, and they're never going to have an age of negative value. So a byte might be the right circumstance. Also, you need to realize that each one of these types requires a certain amount of storage in memory. Different values. So for example, an integer requires 32 bits, or 32 ones and zeros inside of memory to store itself. A double is called a double because it requires double the amount that an integer requires. It requires 64. A byte only requires 8. A string is kind of variable, it changes. A bool requires 32 as well. So those are your different data types, and our job as programmers is to make sure we conserve as much as possible. So those are the data types.